Hi, my name is Abel Siqueira. Welcome to another JSO tutorial. In this tutorial, we are continuing the extension of NLP models to multiple objectives. So this is a very deep tutorial. It involves a lot of the inner works of a model, and it's essentially a hands-on tutorial in which I extend NLPModels.jl to handle multiple objectives. And during that extension, we can, for instance, learn how to do a similar thing, how to make a similar model. So it's not actually a tutorial in the traditional sense, it's more like a watch me work on this very specific topic. Okay, so I made some simple modifications from the last time we were here last week. So what we had the last time that we worked on this, and the one thing that I did offline was I included a license. I believe there was no license before, and I made a repository on GitHub for this model. So let me just show briefly the repository. So here we have the MultObjNLPModels.jl, and you can see that I only have 2 commits. The first commit was essentially the result of the last video, and this commit, this last one commit, just adds license, so you haven't lost much from what I did offline. Okay, so what I'm doing today is essentially I'm continuing the work from where I stopped. A brief reminder of what the work is for those just arriving. So let me close this. I have NLPModels.jl, which is one of the main packages of JuliaSmoothOptimizers, and it defines how optimization problem is interpreted by our packages or our solvers, or how it should be interpreted if you're trying to do a solver using JuliaSmoothOptimizers. And here I'm gonna open the docs. Here, this is the format that we considered. You're minimizing an objective function. The constraints are between lower and upper bounds. The variables are between lower and upper bounds. And you have these functions here in the API to access all of these values. So just a reminder that the Lagrangian, I actually haven't written the Lagrangian here again, but it was written in that last page. We consider the Lagrangian like this, although in none of our functions we have this Z part here, ZL and ZU, because we are always considering the Hessian of the Lagrangian. You can obtain F, C, and you can use the Hessian of L, which involves just this part, with a few of our functions. So going back to the API. So in addition to providing these lower bounds and upper bounds, and the number of variables and number of constraints inside the meta, we provide the function f, the function c, the gradient of f, the Hessian of f, the Jacobian of c, and the Hessian of the Lagrangian. Actually, there is a sigma here we can add, but the Hessian of the Lagrangian function at a point x and lambda. So here are all the functions that we have. So the extension of our NLP models is essentially something that will still provide all of these functions, or at least a subset of these functions, those that make sense, and that will add some more functions to our model. So here we have NLS models, the first expansion that we have, which is an expansion for nonlinear least squares. In addition to having a small f and all of the functions above, you have a big F, which is lower bounded, sorry, I was thinking about something else, which is a vector value function f, which goes from Rn to Rp. So we compute the norm of that. And here we should have a divided by 2 actually. So let me just add here. So in addition to all of the API that NLP models have, we have additional API just for the function f. So you can know the residual, which is f, the Jacobian, and the Hessian of each of the residuals individually with these functions. So this is an expansion already, and we are doing another expansion, which is a little bit more different and focus on multiple objectives. So essentially we have a function f, which is the sum of a lot of functions fi. Okay, so that's it. That's essentially all we are doing. We want, in addition to providing the function, the object, the gradient, and the Hessian of f, we want to look at each individual fi. Okay, so this will allow us to implement uh, a stochastic gradient method, for instance, or work in multiple objective. If you create a abstract MultObj model, and actually I have to decide if I'm using MultObj NLP model or not. Well, anyway, if you create an abstract MultObj model, you can look at each function individually, so you can actually just think of the problem as a multi-objective problem, not as a linear combination of functions. But if you still want to look at a linear combination of functions, you can still use that. And you can use that simplification of multiple objective that considers the linear combination trivially, okay? So for instance, you can look at multiple objective and still use IPOpt to solve your problem. So here we implemented a lot of internals related to an abstract model, the counters, the header, and a lot of functions for the counters here. And we defined what is the expected, or at least some of the expected multiple objective functions. I made a few of the main ones here, and I implemented the other NLP models functions that will be needed in the future. So one of the main ones is how I define an objective function, an individual one. So I extended the obj method to include a new parameter I here. And I have OBJNLP IX. And of course, since I'm gonna follow this signature, which is to say NLP, comma I, I'm gonna use that same signature for other functions. So grad exclamation has structure, has chord, and age prod. Okay. So this will essentially be used by my student, and he's gonna implement one of the methods to define an objective, multiple objective model, and he's going to implement the stochastic gradient method. Okay, so I'm preparing the ground for that work, and possibly others. So in addition to these methods, I'm going to create a few others today. Oh yeah, by the way, we have tested it. So I'm going to use revise. I'm going to use NLP models and our MultObj models. And now I've noticed I had some errors in the another test that I made. They may happen again here. I'm not gonna simply create an NLP there. I'm gonna use this NLP here, which is an example mo NLP. I'm gonna include the example, and I'm gonna say NLP is example mo NLP. And the example MONLP is the Rosenbrock function, and looking at it separately in two objective functions. F1 is x1 minus 1 squared, and F2 is 100 times x2 minus x1 squared squared. So I'm gonna use the weights 1 and 1 here, somewhere here. I think the default is 1 and 1, so I haven't passed. And that's it. So here the objective for individual I, if I is 1, that part, if I is 2, this part, X, I'm sorry, that's not relevant here. The gradient exclamation with an individual I is this. And the H product exclamation for individual I is this. And I have NLP here. If I say obj NLP1 and minus 1.2, 1.0 is gonna fail because I haven't used something that I needed. So this should be NLP models. This is actually a function from our API. So let me check. Maybe it's inside API here. So yeah, I have created increment, but it should be imported from NLPModels.increment exclamation first. Okay. So the import of NLP models increment conflicts with an existing method. Why shouldn't? Let me try closing and opening again. So it's not just that something else is failing. I must have an I should have exported. Should I? Okay, I don't know. There you go. So exporting it works. And the other thing that should work, and this is the important part, if I don't use an individual I, it explodes. So if I don't use an individual I, it says I can't find this method, although it is defined here. So actually, it says that when it calls obj, tries to call, sorry, I changed the camera position and now I'm trying to look directly into the camera. It is trying to call OBJNLPIX. Example MONLP, integer, and an abstract vector. So I'm not sure why it's not working. So maybe it shouldn't be. Let me include again. So yeah, it shouldn't simply. Although it could be a MultObjNLP. So that works. It has to be the specific MultObjNLP models, not the not NLP models, and you can just leave it empty. Okay. So we are going to territory that is not very clear. So if I call multi-objective models dot obj NLPIX, it's my specific model, But here I'm calling OBJNLP without the I. So it's looking into the objective composed of the sum of the objectives, of the linear combination of the objectives. So it calls this function here, and it uses the individual objectives. So if you are defining a multi-objective method, you need to define, for instance, this is what I'm doing here. I'm defining my own method. So I have here, I only need to define for my multi-objective um, the objective, the gradient, and the hprod functions. Here I'm looking specifically at the objective. I only need to define the functions that are important for the multiple objective NLP models. So that the same is true for the residual, the nonlinear least square method. The same is true for the nonlinear least squares method. So if you're implementing your own nonlinear least squares model, you can just define the residual function and the functions related to the residual functions. Of course, constraints are a different problem because you're not looking to multiple. You can't define the constraints by defining the multiple objectives. Okay, that doesn't make sense. So going back, I have defined the objective, the gradient, and the hprod. And my reason to do that was that I could call JSO solvers, which is the package that implements a lot of our solvers. And we have three main solvers here, and one of them being trunk. And trunk is a neutral method which only uses the product of the function with objective. So the problem here is similar. I forgot to include the example again. And now there's something else. Now this is interesting. Here is the unconstrained function. So the unconstrained function inside NLP models. So I can't modify this because it's internal package. Says that there is no method matching unconstrained of a multi-objective NLP meta. But the unconstrained method for this one should be just the same as for the general one. But when we define these unconstrained problems, we use NLP model meta instead of abstract NLP model meta. So this has to change. I'm gonna change it in the future. For now, I'm gonna copy this and I'm gonna make something similar here. And inside meta, I think I'm gonna do it inside the API. Now, I always try to make adjustments only after I'm happy with the current result. So I'm in doubt if I should try to modify what meta and counters are, because it makes sense to first define the meta and then the counters and then call the API. But it makes sense that this model, this abstract MultObj model, should be defined early on so everything can refer to it. So I'm not sure what's the best idea here. And I think I'm gonna create a file. I'm gonna say model. So it's not the model per se. So the API doesn't actually need some counters, show, and other functions. So I'm gonna define a new auxiliary file. In this auxiliary file, I'm gonna take functions that use everything that is kind of mixed. Increment, reset, yeah, everything to here. This is fine. Increment is not here anymore, so remove that. Export increment. I have API now I want to define very early on. Do I need the meta? Kinda. I assume there is something called meta, but I do not define it, so I think it's fine. So I'm gonna define the API, which defines the model and the functions. Meta that defines the derived meta structure, and counters defines the counters. I don't need help for that. NLP types here is the original one. Now these NLP types make more sense being inside auxiliary. They're gonna be after everything, so I'm gonna paste it here. I'm gonna include after everything auxiliary. The names are not final, okay? So this method has bounds, bound constraint, unconstrained, linearly constrained, inequality constraint, and equality constraint. They are all defined. I'm gonna change a little bit the formatting here. They are all defined for an NLP abstract model. They are all defined for NLP model meta, and I want to define them for. So just a moment. I want to define this method. This is a little bit of meta programming, okay? So this is not simple. I want to define for a meta of the type abstract. That is not abstract. For a type MultObjNLPModels. It's gonna be just. I can't define it simply. Because I can't convert them to NLP model meters. So I'm gonna need all of these functions for now. Never mind what I did here. So here to do make these functions more general inside NLP models. And I certainly do not need this help. In all of these functions, I want to remove NLP model meta. I don't want these. And I'm gonna change to MultObjNLP meta. There you go. So this should work now, except that I might have to import. So this should be the equivalent to importing it. Okay. And I can define this for an abstract. I don't need to define these actually because they are already defined for a general abstract model. So let's check again. Unconstrained should be true here. And it is true. So it works now. Unconstrained. Is it bound constrained? No. Is it equality constraint? No, and so on. Okay, so I can call my trunk method again and it works. Okay, so trunk method works, took 15 iterations, and I can see the solution. I can print the output for more information. First order stationary, objective function, primal, dual feasibility, this solution itself, number of iterations, and elapsed time. So this is one of the magic things about using NLP models. You can simply extend the NLP models, and things that worked before will work now. Okay. And this means, for instance, that if you're having, if you're trying to implement a method that's very specific, and you're gonna say, I'm gonna have to compare this with a solver that is not made for our specific model, you can do that because now you have a way of using the non-generalized version. So if I make a method specific for, if I make, when I make the, well, actually my student, when my student makes the stochastic gradient method, for instance, he can just call trunk and compare against the Newton method for the linear combination. Okay, so there is a direct path for comparing our method with previously established methods. So okay, this is done. If I try LBFGS, should be the same thing because only uses the gradient, so it's less. It uses less things. This is just a warning, so nothing here. Tron method should work as well. There you go. And now for the good part, we want to use IPOpt. And IPOpt should not work. For now, of course. It should work eventually. But it won't work now. Take your time, IPOpt. So here, if I change to IPOpt, it's gonna fail because of has structure. Or because of segmentation fault. Anyway, same thing. Okay, just kidding, it's not the same thing. But it fails because of a segmentation fault that I'm not sure why happened. You can try to find out. So I try to solve the problem, of course. Yeah, it's not clear why it failed. But essentially what should be a good reason for it failing is here. This is the way that IPOP works. You define the functions and then you call the method, and it kind of uses it as a callback. So we have the gradient of f, the objective function, and the Hessian. So these are the things that are used. And the Hessian, it will try to call, has structure, NLP, rows, and calls. So I was actually just expecting it to fail, but I don't remember. Yeah, this is why it's failing with a segmentation fault. My implementation of has structure is not done. I'm not doing anything, so of course it's gonna fail. But I left the function here, so when it calls, it doesn't fail because of the function call. It fails because, well, because it's broken. Okay, the memory is not being used, so it's trying to use uninitiated memory or something like that. Let's go to how do I define this hash structure, and how and the implementation of our example for this hash structure. And the thing here is that for my hashing, I'm gonna need, for the sparse hashing, the way we work with the sparse hashing is that we consider the non-zero elements on the lower triangle of the hashing, and we have to store those elements, even if those elements are repeated or if they are zero, it should work, okay? Because IPOpt and Julia as well, if you call sparse rows, calls, and vals, it understands that it could have repeated elements or zero elements. So what we're gonna do is that we're gonna define the structure of the hashing of the linear combination as just the collection of the structures of uh, of our individual functions. So what I'm saying is that since we don't need this one, since my hashing will be something like a sum of sigma I and each of the individual hashings, what we're gonna do is we're gonna say that here use the individual rows and calls of each one of these functions and create a single individual function. So this could potentially break a method because of the way it is defined. So for specific methods, this can be improved. But for a general method that has no knowledge of how those functions are, this cannot be improved, and it will simply try to allocate memory for every individual functions and use all of these memories, all of that memory, okay? So that's one of the things my student will work on, but that's too soon to worry about that. So in essence, what I'm saying is that the rows are gonna be the rows of the first to the rows of the PF, and the columns are gonna be the columns of the first function, the columns of the function sub B. And for that, we only need to say that the I have NNZH, so NNZ, I have NLP.meta.NNZH, NNZHI, I think. Wait, let me check. Meta. Have an NZHI, yes, each individual one. And I have an NZH, which is the full hashing. So we're gonna have some problem for constraint methods, but I'm gonna worry about that in another moment. For the constraint methods, we should first make sure that, so len check. By the way, I'm not using len check here, and I should. So len check NLPModel envar x. Len check x and g, and here in this hprod, len check x, v, and hv. So first I have to make sure that hrows and hcalls have NNZH. I'm gonna change the name to rows and calls. In here to vals. Then I'm gonna go. I'm gonna need a index which is gonna be 1 to NNZH1, and for k for I equals 2 to NLP meta and obj, I'm gonna call with a views the has structure of rows at those indexes, rows and calls at those indexes. And I'm gonna update the indexes. So actually I think this can be done in this way. I just need a counter for where I am. So C plus 1. And then I say C will be increased by the last value in C. Actually not increased. And then ZII. And here I'm gonna say NNZI. And now yes, it is increased. Okay. I think I'm doing this right. Let's check. So we're gonna have to activate this again. Use revise again. Use NLP models and MultObjNLPModels again. Include example.jl again. Create example MONLP again, and then we're gonna call has structure of NLP. There you go. No method matching has structure of a subarray. And why is that? Because I forgot the I here. Okay. Now it should still fail, but it should fail for the correct function. Yeah, an int. And finally, we're gonna go into the example where we're gonna implement the has structure for the individual function. MultObjNLPModels.has structure for this example NLP, for integer, for those rows which are abstract vectors of integers, and let's check. I'm gonna need to see that the size so here I have to compute the Hessian of this function, which is the derivative of this one, and I'm gonna differentiate this with respect to x1 is gonna be 2, and everything else for this function is gonna be 0. So and this function is the opposite, is gonna have elements for every situation. So that means that my length check is gonna depend on the I. So I'm gonna say that length check 1 for rows and calls in this case, and 2, no, actually 4 for rows and calls in this case. And I'm gonna include, I don't increment in this case. What is rows in this case? Rows should be equal to 1. They are actually size 1, so I can say rows and calls should be identically 1. I'm gonna use rows 1 to help our friend the computer a little bit. Second, I'm gonna have rows. I'm gonna create some intermediate memory here. And I'm just trying to remember the order in which I do these things, but there is no need for that. It's just the first element, then the element above, then the element of the row 2, column 2. So this is actually just 3 elements because I don't store the upper triangle. So I have row 1 and 2, and columns 1, 2, 2. So this is my has structure. Let's see if it works. Include has structure of NLP. So almost worked because our NLP should have NLP.NNZ age equals to 0. So yeah, the first thing that is very odd is that I haven't defined the number of non-zeros. So if you look into NLP meta NNZ age, it should, oh yeah, it should work because the default size of the NLP NNZ age is the full size, which in this case is 3. But so that's why there are 3 elements here, but still doesn't explain why it works. So NNZ age is gonna be 4, and NNZHI is gonna be 1 and 3. Let's try again. Include. And then now it should fail. The fact that it's not failing, is a failure. Okay. By the way, where is hprod? Did I not? Oh my god. I simply cut hprod exclamation. No worries, we're gonna use git kraken for that. So I'm gonna cut this little fix here. Example has structure, so it failed. Going back to why it failed, we're gonna look into the API again and try to understand everything that happened. So which function is called when I say has structure NLP? The has structure function that calls has structure exclamation. So which function is called when I call, let's say, first NLP meta NNZH? I forgot to update it. There you go. So now we have something a little bit more interesting. I forgot to update the function, so here. These are wrong. It should be in meta. Include and call again. There you go. So if I call has structure NLP, now I'm gonna have these elements correctly defined, this element wrong, and this element wrong. So where is it? So here we found out that it is still doing something wrong. We had found that out, and I think I know where it is doing something wrong. Here, I forgot to say add C to everyone. Almost worked. So it made some improvement. For some reason this is 0 now. It's not a great improvement, but let's try saying what it is doing internally. So it's calling, yeah, now I should call 1 and includes in addition. So now yes, it is calling 1 1, and it's saying now G not defined. So the problem is different. It is now something related to our method in particular here. So no, wait, where was it called? Oh, there is a G here. There's still a G somewhere. Oh, I forgot to include again. There you go. It's working as expected. Okay. So the first 1, 1 is for the first objective, and the second 1, 1, 2 and 1, 2, 2 is for the second objective. So if I call has structure NLP1, I want it to work as well and just provide 1 and 1. But it won't work now because I haven't implemented that function. So that's one other function that I need to implement. The same way that if I call grad, it should work. If I say grad NLP at NLP meta x0, it should work. If I say 1, it should work as well, and it is not working. So this is something for the default NLP to handle. So here we're gonna have default NLP method evaluate the gradient of the if objective function at x not in place, and this grad function is gonna be an abstract MultObjNLP model for integer, an abstract vector, and it's gonna simply, let's first length check that meta envar x is the correct size, and range check that is 1 NLP meta envar I is the correct range, and I think I need NLP models dot range for this one. So I'm gonna create the memory here, zeros L type X NLP meta envar, and I'm gonna call grad exclamation NLP IXG. So that's how it works. I create the memory and call the method. It's gonna be the same for has structure, with the difference that I'm gonna copy all of this because I don't have the time. So here has structure. The not actually I did not need everything. Just need the integer. Yeah. So I'm gonna copy this. Length check is not needed. Range is needed. And here I'm gonna compute rows and calls. And it's gonna be a vector of integers of size nnzhi I. And I can just call has structure exclamation NLP I rows and calls. And now if I call just grad for 1, it should work now, but it's not working. So no method matching grad I x. So it should. Oh yeah, here. There you go. The gradients of the individual functions. Okay. Whether they are right or not, is another topic. NLP meta x0 is a vector of zeros, so yeah, It is working. Actually, I thought I fixed NLP meta to be minus 1.2, 1.0, but apparently not. And has structure, which is the other one. For NLP, it works. For NLP1, it works. For NLP2, it works. And that makes me happy. Not that I show. And where is it? Calling this IDX is here in the here. So first part done. Second part is the same thing that I did here. I'm gonna do for the has chord. I need to do something very, very similar here, with a few differences. Of course, the number of non-zeros is still true. The length check of the input is gonna be needed as well. And here, instead of has structure, is gonna be a has chord. NLPI rows is not rows, is X. And vowels. And another very different thing is that has chord exclamation for the individual function does not have obj weight. The weight is passed outside. And another thing is that in addition to that weight, I have the internal weight of the function. So after I computed this, I'm gonna say that the indexes are gonna be multiplied by obj weight times NLP meta weights I. I don't need the views actually here. I think I don't need the views here. So let's check has chord. For that I need to implement has chord here as well. Should be easy. Of X, which is an abstract vector, and vowels, which is also an abstract vector. Now, one of the things that made me switch for VS Code is this autocomplete feature. If you notice that I have to write abstract vector, I would usually use an autocomplete that searches for the values in Vim. Here I can say something like ABS and try to write vector, and it figures out that I want vector. It's magic. Okay, so here I need to say length check of 2 for X, and this is true for vowels now. And now I do have an increment, but I want to call the increment only here. And the increment is for the function has. Has? Oh, I have to check. I don't remember. Let's say it must be has I here. So increment has I. Vowels of 1 should be. And now for the fun part, I have to take this information. So vowels 1 is 2 times, it's just 2. Okay, so notice I'm not using 2.0, I'm using 2, so it retains the type of vowels. And here vowels should be something completely different, which is, I think, all of this. And then 1, 2, which is minus 400x1. And then 200. Yeah, I think that's it. Return vowels. Try with a has chord NLP. at NLPMeta x0. Okay, now yes. So I have to include again. And rows are not defined. Of course, they are not defined. Why would they be defined? Yeah, why would they be defined? Here. And there you have it. Does this make sense? Let's figure this out soon. Okay, so the has chord, it will return 4 values because my has structure has 4 values. And it says that, it doesn't actually say this here, but we know that for the first objective we have 1, 1 with a value 2. And for the second objective we have 1, 1, 2 and 1, 2, 2 having values 0, 0 and 200. So we have NLP which was created ADNLP, I think I called it. Well, maybe not, but I can call it ADNLP model x1 minus 1 squared plus 100 times x2 minus x1 squared, starting at zeros as well. And the has chord of this NLP should be the same. So it is the same, it works. Let's use minus 1.2 and the has chord of our AD. Well, I actually haven't compared, I just called the same function. So I was dumb here. So yeah, I have 2, 0, 200, and these are corresponding to 1, 1, 1, 2, and 2, 2. And I know that because I've implemented it. And most importantly, I can call has to check that ADNLP has, well, now ADNLP has this Hessian or this lower triangle of the Hessian, and I can try to call has for NLP, and it works as well because the default has calls has chord and has structure and creates the Hessian for you. Another magic thing. It's a kind of magic. Okay. So by the way, I have to punctuate everything that I say with a music. So there's some problem here that I'm not sure what it is. Possible call error. It is not a call error, so don't know what it expects me to do. So anyway, so has is defined, has chord is defined. Again, I forgot, I need to say the point, and I need to define has chord for 1 and 2 now, which is back in the API, and it's up here the same way that I've called has structure. I'm gonna want to call has chord without the vowels and the exclamation mark. Evaluate the objective Hessian, rewriting vowels. So no rewriting vowels anymore. And has structure is gonna become has chord, and X is gonna be necessary. So the range check is here, the length check of X. Vowels is gonna be a vector of type X with size and then ZHI, and I'm gonna call has chord NLPI X vowels. Let's try again. Working as expected. Now I want to make sure that the other function call works, which is with object wait. So this is half of everything that it works. Notice that it should not work or I don't care for it has scored 1. Okay, at least I don't think I care for it has scored 1. Maybe in the future. Okay, so this is great. The best thing that could happen now is if I call IPOpt and it works without a hinge. And it doesn't have IPOpt defined, so it's gonna be harder to work if you don't have the package loaded. So let's do it, calling IPOpt. Apparently it worked. I'm gonna print the solution. Yep, and I'm gonna increase here so we can see. The solution is essentially the same. Of course, it's a different method, but it's converging to the same point. The multipliers here are not used at all. They actually have been updated, but I haven't updated NLP models, I think. So here it is, converging, working, everything as expected. Okay, 36 function evaluations. Pretty good, I'd say. So notice that it says the number of non-zeros in the Lagrangian Hessian is 4. Actually, the number of non-zeros is 3, but we are using 4 elements to describe the Lagrangian. Okay, so this is this is everything essentially that we need for essentially my students project. That's the main thing that we needed. Okay, so that has everything that we need almost. There are a few things that are gonna appear on the fly that are gonna become necessary when we continue implementing functions. Here I have hprod exclamation, and I don't need that. Evaluate the product Hessian with vector in place. So integer abstract vector and v abstract vector. What is the function? Check the input x and v. Check the range. And by the way, I just noticed that the range is not correct here. It should be NObj, and I might have done it several times. And that's why the next step is to write some tests. Okay. Here. I'm gonna allocate HV, should be zeros L type X, NLP meta, NNZ, no, it's not NNZ, is NVAR. And I'm gonna call hprod exclamation NLP IXVHV. Okay, so I have the main functions here, everything almost as one would want it. The other thing that I want is I'm gonna need to go back here to NLP models to get the API, the complete API. So the other thing that I want, or actually I could just look into the API list. So obj grad, maybe I want that. I'm not gonna worry about it now. Grad has, I need. Has OP, I need. And that's it. The others are just the general function. So I need has and has OP. And I'm gonna search for has. copy and pasting. Evaluate the objective, the if objective at x as a sparse matrix with objective function scaled by obj weight. No obj weight here. Sparse matrix. That's it. So has NLP abstract NLP model is gonna become abstract MultObj model for a vector x. Check the size. I need the integer. By the way, notice that this works for NLP x, but it doesn't work now for NLP 1. Okay, for now, because I broke everything. So here I'm checking the range should be correct. I'm checking the input, I'm checking the wrong thing as well, it should be here. I'm checking the x, it's correct. I'm gonna check the range, and then I call has structure NLP I, and then I call has chord NLP I, and that's it. Remove obj weight, sparse rows calls vals, and NLP var NLP var, and sparse. So I need to use sparse. Where am I gonna call sparse? Could I call here? Using NLP models, I'm gonna use sparse arrays as well. Okay. There you have it, NLP 1, 2. And now we can make a simple test. I'm gonna say S H of x is gonna be has NLP no. I'm gonna say, yeah, that's fine. NLP meta dot weights 1 times has NLP x plus NLP meta dot weights 2 times has NLP x 2. I forgot the 2 here, the 1 actually, and 2 first. So S age of ones is here, and if I say has of NLP ones without the specific S age is the same thing. Now I'm gonna change NLP meta weights for something completely different and check again. Okay, fine, and yep, same thing, it's working as expected. Okay, cool. Now the other one I said I needed was age prod. Age prod, no, actually has OP. Has OP, it has a variant here for the constraint, which we do not want. And it has a couple other variants that we're gonna ignore for now. So has OP NLP I, no obj weight. Return the objective hashing at x with objective function scaled by no as a linear operator. The resulting object may be used as if it were a matrix. Okay. So an I here. And I need to check range check. So what is the prod? Is age prod with an I. And that's it for the first has up. The second has up is has up exclamation, which also uses HV here. Then the objective something something, comma, storing comma, storing the result. Let's cut it here. The resulting object matrix, e.g. this can be removed. Here and this here, following the order in the original help. I'm gonna push the boundaries a little bit. So return the objective hash at x as a linear operator and storing the result on HV. So it doesn't make any sense now. With objective, return the objective and storing the result of HV. So this is storing the result of as HV is wrong in the help as well. Let me write that down. The resulting object may be used as if it were a matrix. The vector HV is used as pre-allocated storage for the operation. So essentially what I have in addition is HV, which is an abstract vector. It should have size n var. And here when I call hprod, I call hprod exclamation mark, and I pass HV as well. So that means that I can have a kind of matrix operation. I can have something that looks like a matrix, which is a linear operator, but I can allocate the matrix and I can have it efficiently. And I need to say exclamation mark. So efficiently in the matrix sense. These rows calls vals HV is not relevant because it does not depend on I. Same thing here. So this is everything for API so far. I could have other methods here, but I don't really need them. So as an example, has up NLP1 at once. Yep, closure not found. I have to add something. What is it? Is fast closure, something like that. Fast closures here. So I'm gonna add fast closures to my compat. And here in my project, take your time. And here in MultObjNLP, I'm gonna use fast closures. So our strategy here is saying standard lib, external packages, and now JSO packages. And then everything else goes in the same line. It's just that I have one of each here. Fix here. Fast closures is installed. I'm gonna go into the project and add a compact here. Compact fast closures. NLP models should have something as well. I'm using 013. And then that's it. Let's has up. Oh no. Due to a previously reported error. Okay, let's see. Revise errors. Closure not defined, but I'm using. Oh, I forgot to use. No, I am using fast closures now. Yep. Fast closures. I think I'm gonna have to close Julia and open again. Let me cut this again for your benefit. activate, using revise, using NLP models, MultObjNLPModels, include example.jl, using NLP models. I don't think I need IPOpt anymore. Okay, I don't have sparse arrays in the dependencies, so let's add sparse arrays. These are from the standard lib, so they are quick to install, or almost. There you go. And then I created an example MONLP. And then I'm gonna call has up. And then it's gonna fail. So no method matching has up NLP1's stuff. So here in the API, what do I have with a has up? NLP. So I don't want to say anything, but this has up function looks an awfully lot like this one. Just saying. It is saved. I guess I haven't saved before. No, I have. No method matching has up. Oh yeah, forgot to abstract MultObj method. Same should be happening here. And MultObj method. Almost again. Example MONLP again. Why is this not being called? Do I need to export this function? This is a question that I haven't checked. No, the problem is obj weight. Oh, actually, this shouldn't be a problem. It should work. It just shouldn't work, but it should work. Linear operator now. Okay. Now, L, so linear operators goes first. I add linear operators and I add, so linear operators should be 1.1. I'm not sure if I need 1.0, but I think I can't have. Now it works if I use the prefix, but without the prefix it does not work. This is kind of annoying. I'm not sure if I need to, because I haven't used this port function for the other methods. I haven't used export for obj or anything else. If I say obj here, it's not working anymore. So it worked in the past. So let's see. Obj. So now I changed to MultObjNLPModels.jl here, and it stopped working, or it started working previously. Now it's not working anymore. I include example, I call obj, and it says that does not exist. It says that it only finds this function here. Well, actually it says the problem is no, it's because this is an integer. So I am exporting obj. If I say NLP models, if I say MultObjNLP models dot obj, it works. So do I need to import NLP models obj and then call obj and export obj? No, because now it says that it conflicts with an existing identifier. I do have NLP models here dot obj. And the strangest thing is that since I have object, let's see what happened right after I started it. So nothing was, no warning was sent here. Of course that I wrote everything top of one another, but then again, or could it be that this is the problem? Let's see. Now I'm gonna include the example, create an NLP, and call obj NLP meta x0. Now both methods export obj, so I can't export the obj from both methods. So export is wrong. Apparently. Now if I call obj, maybe because I have already exported it, now I can't use it. So the next step here will be the following. I'm gonna create a test so that I can just say test and it would work quickly, the whole part of restarting the environment and everything. But I'm not gonna do that today. That's it for today. I'm gonna work on that just maybe on another day this week, this weekend. Or if not, I'm gonna work on this again next Wednesday. So thanks for watching. Please follow me on my YouTube, my Twitter. Follow me on Twitch as well if you want to follow this coding live. And thanks again for coming. I hope you have enjoyed it, and I'll see you next time.